All right, welcome. We're doing the energy transfer experiment, our grounding experiment for learning target 4, work energy. We have a different sort of wild guess. It's sort of an engineering wild guess prediction. So we have some friends, grandparents that need to pull a 2 kilogram cart with a max force of 8 newtons. That's their max strength. And it has to get to a height of 0.8. So the students need to figure out how long to make that ramp so that the grandparents will be able to pull that cart up. We have really 2 groups going on here. A and B are really the same group. They're going up to 0.2 meters high, and groups C and D are going up to 0.4 meters high. They're going to plot something different when they get to the whiteboard session, but I'll leave that till the whiteboard session. Okay, the experimental setup is fairly straightforward. We're going to use our low friction carts with a spring scale and put the cart on, and you need to pull it until it raises up 0.2 meters. So it's not enough that the books are 0.2 meters up. We want to make sure the cart rises up that far. Otherwise our distances will be off. So this is 5 centimeters off already. So I'm going to keep pulling it at a constant velocity. So I'm only transferring gravitational potential energy until it gets up 0.2 meters high. And then I'm going to write down the force and the distance it actually took to do that. Then we'll reset the ramp, and with this new I need a much shorter distance because it's steeper, and I have a new force. And of course we want to maximize the range all the way to vertical, which means we're basically just lifting the cart up at a constant velocity so we get a max data range. Group C and D, then we'll just stack 2 sets of books and raise it up to 0.4. Now this is nice because it's going to set us up for a great whiteboard meeting. Students can really build a lot of good science practice skills here, transferable skills to the rest of their lives. The big idea is there's always a trade-off between force and distance. You always have to pay the piper. You always have to put the energy in, but you can do it 2 different ways, through the force or the distance. The combo of them is the energy transferred, also known as work. So we get to the whiteboard session. We're going to have 4 different whiteboards, group A, B, C, and D. Now we're really going to focus on these 2. The pattern is inverse with force and distance. And of course, after they get good with that, we'll ask them some questions about proportional reasoning. We're going to start focusing on why is the A value 10, but over here the A value is 30. They're the same pattern, but one's shifted up. And then, because I also have them draw the experimental setup, they realize everyone that's shifted up did the 0.4 meters. Oh, so it's height related. The bigger the height, the bigger the A value. Excellent. And that's why we have C and D down here, because we want to move them from height to energy transfer, MGH. And that's going to be nice because we'll say that's 10, and then we look at this one, and this, of course, is a flat line pattern. The distance doesn't affect the energy transferred, by itself at least. All right, so then notice this flat line is at 10. The A value is 10. That's what we're going to use to get them from understanding intuitively height matters to it's not just height, it's MGH, or the energy transferred. And nicely over here, the energy transferred is 30, the A value is 30. So we have both of those reaffirming it. And again, we have a flat line with force applied versus energy transferred by itself. So in each case, it's the combo of force and distance, not force alone, not distance alone, that determines the energy transferred. One last thing to say is we're beefing up the conclusions. So lots of us are feeling that they're getting good with these conclusions, and we want to add some more creative elements. So there's 2 statements that we want to add. After stating the mathematical model, you now need to apply it to a real life situation. And then after stating your reasoning for confidence, you need to add another sentence that explains limitations on your experiment or limitations on the model. I have a couple examples in the slides you can see. We also have a simulation coming up, and we're going to do more simulations. So a limitation is that we did it on the computer. So there's some ones, and you can see the examples in the slideshow. All right, thanks.